can walk through. This is 11 through 20. For number 11, so you're running this procedure where you have this sample that has dissolved solids and suspended solids. Total solid is not a different kind of solid. It just means the totality of the dissolved and the suspended solids. So basically, you take a portion of that sample, you just boil it off, and then that gives you mass 1. You conduct a separate trial where you filter it first and then you boil it off, and that's mass 2. So the first step you probably take is to realize that total solids has to be mass 1. Because if you have something and you literally just boil it, the solids are all going to drop out and the water's going to evaporate. So the solids are what's going to be left over. So you can automatically eliminate C and D because it doesn't say mass 1. And if you look, A and B have opposite definitions for suspended and dissolved solids. But how you figure that out is suspended solid means the particle, the solid, is too large to be like dissolved by the solvent. So if it's too large, that means it's going to get caught by a filter. So if it's sitting up in the filter and everything else is down in a different beaker and you boil off the stuff in that beaker, what's left over is going to be only the dissolved solids after you boil the stuff, because the suspended solids you already caught onto the filter. So that's why A would be correct, because DS has to be mass 2. Okay, so moving on to 20. What can you do to determine the concentration of nitric acid? Okay, so I don't know why I called it I. It's obviously correct. That's the normal thing to do. That's probably the first thing you learned in your chemistry lab. For 2, the reason you can't treat with a standard oxidizing agent is because nitrate can't be oxidized. The N in NO3- is already at a +5 oxidation state. You can't go any higher than that for nitrogen, so 2 wouldn't work. And if we look at 3, good luck precipitating something with the nitrate anion, because it's just not going to work. It's super soluble. 13. So the kinetic theory of gases. A is like just the definition of a gas in the kinetic theory, and these refer to assumptions that you kind of have to make in order to assume something's a real gas or ideal gas. When you're dealing with real gases, you would have to use the van der Waals equation. That's a whole nother thing. Probably you don't need to learn it for the NCO. But basically, B and C are assumptions that you make. A is just the general definition of a gas in that theory, and D is just not contained within that theory. Because if you think about it, the implication of gas particles colliding and kinetic energy being lost is that eventually the gas particles just like stop moving, because you can't move if you don't have kinetic energy. So that's why it'd be wrong, so you'd pick it. 14. Temperature and volume are halved. Okay, so it's not even like a hard vapor pressure question. So if we look at the ideal gas law, if you have 2 things, you have this and they're opposite sides of the equation, it literally doesn't matter because you just multiply both sides of the equation by the same thing. So pressure would be unaffected. It'd just be the same. Looking at number 15, dichloromethane. Experience which of the following intermolecular forces? So everything experiences dispersion forces, because if you have a mass, if you have electrons, you're going to experience it. It does experience dipole-dipole forces because, as far as I know, I think the CLs are next to each other. Next to each other as in like not opposite. So like that. So that would make the compound polar, and the reason it's not hydrogen bonding is because you don't see a hydrogen bonded to a NO or an F. Which property best distinguishes metals from other types of solids? Okay, so this, I didn't really know the answer to it when I took the test, right? But I was able to get it by process of elimination, and that's because, okay, so like just going through the choices. Metals exhibit 3D order. That's true of every solid. That's the reason they're a solid. Metals melt at low temperatures. That's just false, so you wouldn't choose that. Metals have a shiny, silvery white appearance. It's tempting because in your mind, that's probably what you think a metal is. That's the picture that pops up. But it's not right because not all metals have that appearance. For example, just like pure copper is red. So that leaves you with D, and that's why you choose it. Number 17, this just like digging into the memory banks. So if you have this, which is a silicon carbide, there's like carbunderum or like some other weird name for it, but I just call it silicon carbide. Or you have silica or silicon dioxide. These are the two poster children in the USNCO for coordinate covalent solids, network covalent. Number 18. The normal boiling point and vapor pressure are measured. Okay, so flask B is going to have boiling point elevation because you have a non-volatile substance in solution. So basically what that means is that you put stuff in flask B, it's going to boil at a higher temperature. Basically the attractions of Na plus and Cl minus are kind of holding the water together for longer, so it's going to make you go to a higher temperature to claw them apart, if you will. So higher boiling point has to go to flask B, and inversely, higher vapor pressure would have to go to flask A because it boils at a lower temperature, so it's more willing to become a gas. Number 19. Okay, so it's just Hess's law addition. So if you look at what you have to add, the only equation that SO2 is in, so SO2, it's only in this one, so you'd have to multiply this value by 2. Let's see, the only equation that water is in is this one, so you'd also have to multiply this one by 2. And where I'm pulling these 2's from is these coefficients right here. And H2S is only in this equation, so you'd have to flip it and multiply it by 2. In other words, you multiply by -2, and if you add these all up, which I'll do right now, -268, 296, oh, I can't speak today, times 2 plus -285.8 times 2 plus 41.2. That gets you -1124. So that's why we choose D. Last question for 20. Which reaction has a negative standard enthalpy change? Okay, so you're basically just looking at the states of matter the reactants and the products are in. So for 1, you have 2 moles of gas on the left, and you have 1, 2, 3 moles of gas on the right. So overall, you're increasing in moles of gas. You're going to be spreading over a larger volume, and you have 2 different types of compounds instead of just 1. So more disorder, more ways for energy to be dispersed, so that would have a positive enthalpy change. Entropy. I might have been saying enthalpy this entire time, but it's entropy because it's S. And 2, you have 2 moles of gas in the reactant side, and you have 0 on the product side. Yes, you do have 1 mole of solid and 1 mole of liquid, but they're super constrained. They aren't as free to move around and disperse energy as a gas is, so that's why you have a negative delta S for 2. And it's only 2, so that's why you choose B. Okay, next video we'll do 21 through 30.